Okay, today our presenter is going to be Mr. Rob Sink, and probably several of you know Rob or worked with him before. He's been with Yokogawa for 27 years, and he's been working with our control products for most of that. He has experience with other products as well, recorders, data acquisition, and flow meters and things of that sort. He routinely works with customers answering control questions, helping them solve their control problems, and implementing control strategies using our products. He's a very valuable resource to our team and actually an expert in using our temperature controllers and temperature controllers in general. So we hope to, the information he's going to give you today is going to be quite valuable. As far as questions go, I think hopefully you'll have questions during the webinar. The questions we're going to take through our Q&A window, and you'll see that in the upper right-hand corner of the screen. Click on that, and then you can type a question to us. When you do that, please type that to all panelists. There are more, Rob is here, I'm here, and there's others here as well, and we'll be monitoring the questions and feeding those to him. So please send the questions to all panelists so that we all can have access to it and hopefully get the answers that you need. If we're not able to answer all the questions for you today, we will forward those to you in an email after the webinar. So we'll make sure we get your questions answered. After the event, there will be a short survey. If you don't mind taking that, that'll help us in making these webinars better in the future. Also, please stick around. Don't cut out too soon. We'll be having our drawing for our free book offer. So we, and if you did get the invitation, there was a book offer there. And a book offer is like 2 heat treating books. The value is like $300. So we want to make sure that you are here and can stay for the drawing on that. Okay, without further ado, I want to present Mr. Rob Sink, and I'll leave it up to you, sir.
Thanks, Clayton. Let's go ahead and get started here. What we're going to discuss today, a number of topics. We're going to start off with what is set point ramping, why set point ramping is necessary in temperature control processes and when you should use it, how do ramp soak segments work, what are guaranteed ramp and guaranteed soak and when you should use them, how to use events, and what is recipe management. Basically, a control recipe is also referred to as a program, a profile, a program profile, a pattern program, a pattern, or simply a ramp soak profile. These terms are usually used interchangeably in the heat treat industry. Let's take a look at some of the components associated with program patterns. First of all, we're going to talk a little bit here about set point ramping. And basically the definition of set point ramping is the increasing or decreasing the effective set point towards the final target set point at a predefined rate. A normal set point change where the current set point is changed immediately to the new desired set point is not usually or not always desirable. For many applications, a gradual increase or decrease to the new set point has its advantages. And in the slide here, you can see the difference between the two, where we have a normal set point change. We'll go in and change, say, from 100 to 200 degrees. The controller will immediately bump up to that new set point, and it is possible for the controller to overshoot since the deviation between the temperature and the set point is large. Over here, we have set point ramping, where we just have a gradual change in the set point. When should we use set point ramping? To prevent or greatly reduce set point overshoot, to prevent thermal shock to the product and furnace or oven, to eliminate the need for manual startup, and also to prolong the life of hardware components. Set point ramping calculates numerous subset points that the process will reach before finally attaining the target set point of a particular segment. In doing so, the difference between the set point and the actual temperature is greatly reduced. As the controller moves from the sub-set point to the next, a smaller change in output is needed than in the normal set point change. This in turn will prevent or greatly reduce set point overshoot. Thermal shock occurs when there's a rapid, uneven temperature change to parts or product or even the furnace components, including the refractory. When set point ramping is used, drastic temperature change can be eliminated to prevent thermal shock from occurring. In some applications, it may have been necessary to start the controller up in a manual type mode and have operators adjust the output manually until a desired condition is obtained. This could be eliminated with set point ramping. Set point ramping will also prolong the life of the furnace hardware components. Since the sub-set points are changing by a smaller value, valves won't need to slam open or closed, and SCRs and heating elements won't have to work as hard due to large temperature differences. And in this little graphic here, we can see where the operator has changed the set point to the new desired set point, and we're employing set point ramping to ramp up at 5 degrees per second, so we have a nice smooth transition up to the final target set point. How do ramp soak segments work? A ramp soak profile is comprised of multiple segments. Increasing or decreasing the set point over time is called a ramp segment, as seen here in the graphic. We have multiple ramp segments. Maintaining a particular set point during the program is a soak or a dwell segment, where we're just maintaining that particular temperature. Before defining the individual segments in a pattern, it's necessary to define the time units, usually hours and minutes or minutes and seconds. It's also necessary to decide what segment time setting method you would like to use. Typically, there are two choices: ramp rate, for example, 30 degrees F per minute, or simply time. And here we have an example of the ramp rate, where we're actually specifying so many degrees per minute in each of the ramp segments that you see here. Soak or dwell segments just require a time setting. Heat treatment temperature mainly refers to a soaking temperature and time. The soak temperature and time significantly affect the material properties of parts. So soak segments will instruct the controller to maintain the set point of a particular segment for a certain amount of time. An example would be the soak segment set point was 500 degrees Fahrenheit, and we would maintain that for 6 hours. And in the graphic here, we have multiple soak segments at different lengths of time. Another aspect of recipe management is the guaranteed ramp and soak features. Guaranteed ramp is simply a way of making sure that the desired ramp rate is maintained during a ramp segment. During a ramp segment, there are many things that could affect the ramp rate of the process. Events such as change in process dynamics that would affect the effectiveness of the loop tuning. As the temperature changes, the process responds differently to the PID values. Steam pressure or chilled water could affect the ramp rate as well, if they're using that in a particular process. Other events such as user interaction with the process, like opening a door, could affect the ramp rate. In a guaranteed ramp, A temperature band is placed around the ramping set point, and as long as the process variable remains within this band, the process continues. If the process variable exits the band, then the controller set point ramp is placed into hold and waits for the process variable to recover before continuing. As you see, we're in the graphic here, we're ramping up, trying to stay close to the set point, but something happens during the process. Maybe a door is opened or a fan is on inadvertently. The temperature starts to drop down. This dashed line here is our lower side guaranteed ramp zone, and we're actually dropping below that point. So the controller will pause the timer and wait for the process to try to catch back up. And once the process comes back into this band here, then the timer will start again and the program will continue as normal. For the guaranteed soak, that's what we're going to be using in a soak segment, hence the name. It's a way of making sure that the process stays within the desired temperature band for this particular soak segment. Normally in a soak segment, the controller will try to maintain this set point for this length of time. Much like the guaranteed ramp, it is possible to set a band around the set point and have the controller pause the segment timer if the temperature goes outside of the band. Once the temperature recovers, the segment timer continues. This is extremely useful when, for example, a group of parts need to be held at 500 degrees for a total of 2 hours. So again, here we have a target set point here in green. We have our process variable, and we have this is just one segment here. So we're approaching the temperature. Something happens in the process where our temperature takes a dip and actually drops below the lower side of the guaranteed soak. And this is where the wait operation begins. The timer is paused, and the controller tries to allow the temperature to come back up. Once it reaches back into this band around the set point, the timer is started again, and the controller will try to get back up to temperature and finish that particular segment. Going along with the ramp and soak segments in the controller, we also have the capability of using events in most controllers. There are two types of events that are generally available in most modern ramp soak controllers. Those are process-based, or what we call process variable events, and also time events. And these events can be triggered in particular segments. For example, here we have process variable event number 1 with different types and different set points going across the whole program. For the time events, we have time event 1 and time event 2 going off and on during different points of the segment. Basically, you can think of process-based events as an alarm that are active while the profile is running. Types of process-based events or process variable events include high, low, deviation, velocity, etc. Process events are usually set for each individual segment where they're needed. They're typically used to trigger a light, horn, buzzer, or alarm to alert the operator of a particular process condition. Process events could also be used for interlocks on our furnace door. In this example, a high alarm set point could be used to close a contact to prevent the door from being opened above 75 degrees. So say the furnace gets up to temperature and it's running, and you don't want the operator to inadvertently open the door and possibly burn himself. That's a really common application for a process variable event. Time-based events make use of the segment clock timer to open and close contacts at predetermined times. And time events are usually set for each individual segment, just like the process variable events. They're set where they're needed. They can be used to signal other equipment that a program is running, that the program has ended, that the program is currently in segment 3, etc. They can also be used to turn on fans, an extra heater, or open a vent, for example. And in the graphic you have here, we have the 3-segment program. We've got the process variable going up. The time events work independently of the process variable. They're just mainly concentrated on the time or timer that the controller is using for each segment. This time event number 1, it's going to be off for the first portion of the program. It'll come on, stay on for a few minutes, and then before the end of this segment, the time event actually goes back off. Segment 2, the time event is off for most of the segment. Right before the segment is over, it goes on for a brief amount of time and then shuts off before we move into segment number 3. And that's just an example of how the time events work. We have multiple events coming on and going off at different points during this particular program. Very useful. Recipe management can be defined in several different ways. In our discussion here, we're going to define it as a way to organize, program, modify, start, stop, and select different profiles on a controller. Most controllers are capable of multiple patterns and perform their own version of recipe management. The controller stores all of the patterns in its internal memory. It is possible to select and run patterns from the controller as well as program and modify them. Along with that, controller manufacturers usually offer recipe management software to make it possible to do these same functions with the use of a PC. Patterns can be uploaded, downloaded, as well as comparing patterns that are on the PC with the ones currently in the controller. This is really useful, especially if you have some people that are going out and making changes to the controller that they're unauthorized to make. You can actually hook up to a controller and with the use of the PC, compare the known good file with what's in the controller, and it will show you the values that are different and allow you to recover and change the program. Other third-party software vendors produce software to do more advanced recipe management. They include Wonderware, Iconics, custom packages created by furnace manufacturers, and SpecView, to name a few. One example is SpecView. It is capable of performing recipe management as well as being a full-blown SCADA package. SpecView is available through Yokogawa as well. SpecView will allow you to create and edit profiles as well as configure and edit the controller. As you can see here, we have a couple sample slides of a project that was built using SpecView. Down here, we can actually construct the program pattern. We've got the different segments here: target, set point, time, digital outputs going off and on. We can also enter batch numbers, current recipe names. We actually have an icon of the controller here that is functional while the program is running. The status screen would show you your batch ID, maybe an operator name, start time, end time. You can actually launch the pattern from this screen as well. In addition to the recipe management here, we also have the capability of trending. With most recipe management software, you can do trends of your process. We even have little bubbles that pop up when our events are happening. We have a soak start bubble here and a soak end bubble here. But very flexible. Most of the recipe management softwares are real flexible, multiple patterns, and just you're able to lay out the software like you want to see it and make it as complicated as you need or as simple to make it very user-friendly for you. Yokogawa's ramp soak controller line is made up of the UP550A and the UP35A. The UP55A is capable of storing up to 99 patterns in its internal memory. The UP35A can hold up to 4 patterns. Yokogawa offers a configuration tool recipe management software package called the LL50, which enables you to connect to the controller and do the housekeeping, programming, pattern creation, and monitoring using that software. Also, by using communication options on these controllers and one of the third-party packages, such as SpecView, it is possible to increase the number of patterns available to them as well as customize the look and feel of the data management. And by using the recipe management software, you're not restrained by having to push the buttons on the front of any manufacturer's controller to edit or change or to monitor what's going on with the controller. Okay. I'm going to have... Okay, let's do the questions before we do this. All right, quick change of plans here. Sorry, everybody. Thanks for
Thanks, everybody. We're going to do the questions first. We had a couple of questions that came in, and we want to go over those first and have Rob answer the questions before we get to the free book drawing here. So, okay, so one of the questions that came in was they want to take a time event, and they want the time event to stay on at the end of a pattern. So when the pattern ends, so does the event. So the pattern ends, the event ends as well, time event. How do you do this? How do you keep the event on when the pattern's finished?
It would have to be a process variable event to keep the pattern on. In most circumstances, you would have use what we call PV tracking. We would go to a local mode and have a local set point entered into the controller. That way, the events would would be active in the program pattern, but also be active after the program was over and when we were using just a single set point control strategy.
Okay, so for a PV event, that would be fine. Just one suggestion on that, I would say on a time event, is you could possibly add another segment to the end of the program pattern. So your pattern ends at segment 6, and segment 7, you add a segment that does nothing. Maybe it's a 1-minute segment. You go to that and put that segment in hold. then at that point, the event stays on as long as you have it track all the way to segment 7. The event will stay on, and you can have it, if it's running a fan or something like that, you could certainly have it continue during that period of time. Okay, there was another question. Sorry. Okay, yeah, that's it. What is pattern creation? So, Rob, you want to?
Sure. Pattern creation, basically it's the recipe or the program profile, the ramp soak segments that we're creating here. That a pattern is just another word for the program or the ramp soak profile in the controller.
Okay. I got one other question here. Is I have trouble with overshoot at the end of a ramp segment. How do I suppress the overshoot?
All right. Basically, there's several ways you can do this. Most controllers nowadays employ what we call fuzzy logic to help create overshoot or get rid of overshoot. And basically, it would be just a matter of turning that fuzzy logic function on. Some manufacturers have different settings, whether it be like a stable mode or a more aggressive mode. We could also do tune the controller differently. We can have tune based on that set point, the PID tuning. Or we could actually slow the ramp down if that's possible. Make the ramp a little longer so you're not approaching the set point as fast.
We at Yokogawa, I'm going to use this shameless plug here and talk about our stuff a little bit, but we have a function in there called Zone PID, which allows us to segment the temperature range. So maybe in a program pattern, I have 3 soak segments at different temperatures. I could set up zones for each one of those and give each one an individual PID set. And by doing that, I get the best tuning at each of the individual soak segments. So that would help as well, along with the fuzzy logic Rob mentioned. And if you are having really tough times ramping, that slowing that ramp down as you approach the set point is a really good tool to do that as well.
And just to add to what Clayton was saying about the zone PID, we also have what we call segment PID control, and I think other manufacturers have that as well. But what you do in segment PID, say you have the process, the dynamics change, say maybe you have a 7-segment program, and in segment 6, the dynamics change. So what we can do is basically assign different PID values for each individual segment, which could possibly help on the question about the overshooting at the end of a segment.
Okay, well, that's all the questions we have. If you have a question, we have a little bit of time.
Yeah, don't be shy. Speak up.
Speak up. Awesome.
We have another question asking about open circuit detection on, for example, thermocouple or heating elements. Definitely on if you bring in like a transmitter or a thermocouple, we have burnout detection for those, as well as we have a feature called heater break detection. We can monitor that to make sure that the heating elements are still working properly.
Now, the heater break that Rob mentioned is an alarm. So as the controller is running the alarm, it sees that there's a problem with the controller output, and it generates an alarm. So it's not well, it's not like a high or low limit, but that alarm is indicated as heat or break. So we do have that as well. And on some of the lines of controls we have an output break detect, which actually sees that the current loop is actually open on the output. So yeah, our controllers, and we do have, most controllers in general will indicate whether or not there is a break in the input or output, and will generate some type of error for you so that you can take action on that. Okay, let's take a look at this. Typically, the detection, you make mention of that, is it hardware or software? It's typically a hardware detection. So if the unit is standalone, you can determine whether the input or outputs are indicated that are open. And typically, there'll be some type of software error bit that you can read over the software, but the detection itself is a hardware function. Okay. Next question is, what type of controls do you have for induction heat treat systems? Well, okay, I'll go. With that, there are a couple things. We have our typical controllers with that are our current UT Advanced product, which work very well with induction heat. The neat thing about that is it has a very high scan time, so cycle time. So the induction heat needs to heat up fast, stay at a certain temperature, and cool down quickly as well. So with having a high scan speed, we're able to control that very easily. So realistically, most of our controllers will handle that, except for our really low-end models. So we have a very low-end kind of an OEM sub $200 controller, but you might have a hard time with that. But most of our other stuff will have no trouble controlling induction heating. And we have several customers doing induction heating systems with our UT Advanced and our YS products with no problem. Okay. Next question. What type of capabilities will you add in the future? Oh, that's a good question. Well, I'm going to be honest with you with that type of question. What we've done, the features in the future are really difficult to determine because temperature control, ramp cells, the whole 9 yards is a fairly mature market. There's not a whole lot of new innovation coming with that, other than the applications are newer, but realistically the functions that you would require are not so new. And I'm going to be honest with you, typically our innovation is driven by you guys, our customers, by them coming to us and telling us, hey, you know what, I'm trying to do X, Y, or Z, and your product doesn't do that, or I'm having a hard time doing this, and maybe we don't make a product or make something that does that. That's when we start adding new features and functions to products. And I'm going to be honest with you, one thing that's really neat about our new current control system, our UT Advanced, is it has the embedded ladder logic. So in the past, and I'm going to talk a little Yokogawa here, is in the past we used to do what we call tokachus, where we take a unit and we custom design it with features and functions that allow the customer to do exactly what he wanted. I want an event to be married with another event that only operates in manual mode when the temperature is above 400 degrees. And something like that, we had to do something custom, and we designed the controller for that. With the new ladder logic features, we just don't have to do that anymore. We can build that very easily, just like a PLC. We put it in there, we build those features to get those conditions together, and just launch it with the regular controller as if it's a configuration file. And then with that, we can add almost any feature we want to the product. So we're hearing less and less from the field as far as, you know, what new features are coming, or can you add these features to our product? So, and we did that just to get rid of this custom building type of deal. So, so what's coming new? The only other thing right now is, Rob mentioned the recipe management is our Y-Heat solution. Y-Heat is, as you know, the PLC is becoming a major part of heat treating, ramp soak, recipe management, the whole 9 yards, and there's a lot of guys doing that now. Yokogawa, you know, we've been doing that for a while too with our FAM3 system. So we've got a package already made that does ramp soak, PID controls, all the 9 yards, the fuzzy logic, auto tune, that's all there, the recipe management. And Rob mentioned that some companies do build custom recipe management software. So our Y-Heat has custom recipe management software, similar to SpecView, but made directly for our Y-Heat package. So it's another way to do recipe management, as well as it's something new. And when I say it's new, it's probably not well known that we have the product. We are marketing it now, trying to get it out there because, again, the market's changing for PLC in heat treat. So we're using this product to go after a lot of those type of accounts and a lot of those type of applications.
Okay, I see another question on here. Do the controllers work with thermocouples, or will they also work with RTDs? And indeed, the controllers will work with RTDs. In effect, the inputs are what we call universal. So you can use thermocouple, RTD, 4 to 20, 1 to 5 voltage, millivolts. It's a universal input, so just about anything you want to connect to it, we can probably take care of it for you.
Okay. Next question. What are the recommended hardware calibration intervals? And must the controller be sent back to the factory for calibration? Can it be calibrated in the field by a service technician? Okay. The recommended calibration interval typically is going to be based on your QA policy, your company QA policy. So if your QA says I need to have this calibrated once per year, and we find that that's the most common, then you know it needs to be calibrated once per year. I think AMS 2750E does state once per year, I believe, and I think that depends also on the device and the function is performing, but it can be calibrated once per year or once every 3 months. It just depends on what quality level that you're looking for. So, but again, most commonly is 1 year. Now, can the calibration be done in the field, or does it need a service come back into the factory? We can check them in the field. So if most of the time you're not going to have a lot of drift with at least the Yokogawa controllers. They're going to be rock steady. So once it's calibrated, your basic function is just to check the unit to ensure that the calibration is still intact. To calibrate the unit in the field is pretty tough. It really needs to be sent back here to the factory to be done. When we calibrate these units, we actually put them on a test stand, and the computer and our PLC goes through it, tests everything, and does the calibration for us. We don't actually manually calibrate any of these units. They're all done electronically through our automatic test stand. So for our products, you do need to send them back to actually physically have a calibration done. But to have it, to check the calibration to ensure that the 10-point calibration, or to ensure that the high or low or thermocouple, J-type thermocouple is where it needs to be, that can be done in the field with no problem. Okay. Any other questions, Mr. Singh?
We still have some time for more questions. If you don't be, like I said, don't be shy.
Okay, next question. Can you briefly describe the process for validating the control and software designs to ensure the products meet the design requirements? That's a deep one right there. And I don't know if I could briefly describe that. Interesting. Are you testing or modeling? What? Yeah, I think so. I think I'm going to probably need to punt on that one, at least at the moment. Let me mention this to you, not because I don't want to answer questions. I'm going to be honest, we just don't do a lot of the validating of the controls, the VMVs or the software and the controllers. Typically this is something we do in nuclear and for our nuclear customers. And we don't typically do that ourselves. We do this through a third-party qualification process through a company called NTS. They pick up the qualification. They do the VMVs on the controllers and the softwares and the software to make sure that it meets the design specifications as well as the specifications for the process. That's what it almost sounds like. It's more of a nuclear industry than heat treat or ramp soak. But what I can do, and I see you, I think it's Larry, I can certainly give you guys a call. And in essence, they are, and they are third-party type tested. Again, we use a validation agency called National Technical Systems to do that testing for us. So we don't test them here, at least for validation of processes and particular applications. And typically, these processes are done for nuclear. So, but what I can do is I can give you a call and just ask, we can talk about that, and maybe I can get a little clear idea of what you're looking for and hopefully answer your question in this case. Okay. So on that note, I think I'm going to punt now, and let's take a look at the the free offer here.
So you want to give away some books, huh?
Yeah, I got a bunch of them, so I'm going to give them away, and hopefully somebody can get some benefit out of them.
Okay.
So what we did while the presentation was going on, we took and we drew names from the list of registrants who registered for the webinar. So we want to go through and announce those to you now. So the first set, and again, this is a set of atmospheric heat treatment written by Daniel Herring. And again, I've met the guy. He's almost a heat treat genius. So these books have basically anything you would want to know about ramp soak, heat treating, metallurgy, the whole 9 yards, and how to control those things. So first winner is Jeff Neer with Astro Aluminum Heat Treating. And this presentation will be saved and it will be uploaded. So if you're, I don't know if these people I think are here. Maybe one's not. But if they're not here, they can come and see the presentation and at least see that their names are here. The second one is Brett Walters with SKF Aero Engine. All right. And the third name is Carrie Roberts at that Michelin Packaging.
Nicholson?
Nicholson, Nick. Yeah. Okay, so congratulations to our drawers, and so they will each get a set of these books, and we'll be contacting you by email by the end of the day and make arrangements to have these delivered to you. So, anything else, Rob?
I think we've already done the questions.
Yep.
Just for questions, comments, and suggestions, we have a support email address, technical support line here, And if you want to, something specific about this webinar, and you just want to email us, just use this email address or call in and reference just Recipe Management Webinar, and we'll be better able to direct that to me or maybe to Clayton or someone for some other questions that you might have.
And also in the upper right-hand corner, you have the chat. If you'll click on that, there's a link there for a survey. So if you are so inclined, if you'll click on that and answer a couple of questions for us regarding the webinar, we would greatly appreciate it.
And we'd like to thank you for attending our webinar today. Again, my name is Rob Sink. I can be contacted at the information listed below. This is our main contact number. That's my email address, and there's also our website. And for more information on SpecView, there's the website for them as well. All right. Thanks for attending, and we will talk to you later.